susceptible to buffer overflow attack. So what the memcopy actually does is that in the memcopy, what you do is that you say something like this. Let's say you have a variable. Let's say you have a variable, which can kind of, let's say, okay, let's say you have a variable which can, let's say, only store 8 bits of data. Okay, and when you, let's say, when any function executes like memcopy, what it does is that it actually copies the memory from the source to the destination. Okay, this is what that software is doing. But the issue with the memcopy is that it is actually not doing any kind of checks like what's the length of the data that is coming in the source. Okay, so that's the reason if the source over here, the one that I have kind of sent out from here, the big chunk of data of A, that is the source, okay, that is a 4,000 byte, it will blindly store that data in the buffer value. And now since the buffer value is only of 8 characters, the 4,000 characters will not fit. And because of that, what will happen is that it will actually, it will not fit, and it will actually overwrite that the additional data will override this part over here that you are seeing right now. Okay, so the additional data will override this data that you are seeing right now over here will be overwritten by AAA. Okay, so this is what the memcopy is doing. This is one of the vulnerability of memcopy. So as soon as an attacker I see memcopy in the assembly code, I'm happy that I can, if I can somehow, I can, at least I can know that, okay, there will be some kind of buffer overflow attack because the memcopy is in action. Okay, because it is not checking the length of the source. Okay, even now, guys, even though it is like well known, now also like what you can see that there will be multiple softwares in real world which will only be kind of hacked just because of the memcopy execution internally. Okay, and it's not just memcopy. There are different kind of other functions like string copy, puts, gets. Everything has buffer overflow. Like they don't check the length of the data that is coming, and then they are kind of reading. Okay, so I'm seeing memcopy as an attacker. I'm pretty kind of knowing that, okay, it might have some kind of buffer overflow attack. And that's the reason, that's the storyline I will make out that, okay, I will now try to kind of attack the system with, let's say, a big value and try to see if the memcopy actually leads to buffer overflow attack and try to crash the system. Okay, so now over here, if I do one thing, now this, now the thing is that this software is running. And what I do is that, so this is the code of that software. Okay, this is the actual code of that software. Okay, and what is this? This is a CPU value, the one that I was telling you of the system right now for this software. So this is EAX register, ECX register, the one EDX register, and I hope now this is making much more sense, right? So this is the value of the register value, and this is the current EIP value, the instruction pointer, and it is telling that it is at the entry point, and it is currently in the pause state. If you see over here, let me just do one thing. If you see over here, the paused, yeah. So currently the software is in pause state. If I just click run, the software will start running, and then you will see running state over here. And that's where the EIP value over here is telling me that it is right now pointing to the module entry point. As soon as I press enter, the software will start running. Okay, and these are the registry values. These are the assembly code, the code, actual code of that. And this is the one that you are seeing right now. And I hope, guys, I'm using a tool to kind of showcase you certain sections in much more interesting way, like using torch. I hope the same is visible on your screen also. Okay, so this is the part which is actually the stack memory. Okay, so this is the stack memory, the one I have been telling from like today, the stack memory over here. Okay, so this is the stack memory, and thing is that this is the register values. Okay, and this is the code. Okay, so now what I will do is I will try to run this one. So to run that, I will click on run. Okay, so it is running, and if you see the status over here, over here, it is running. Okay, and now I will try to again exploit this. Okay, so what I will try to do is I will do sock.close, and I will again kind of try to connect. Okay, let me do that. quickly stop and stop. So now if you see over here, you have received a connection, server got a connection, okay? And this is being debugged in the code right now, okay? And now what I will do is that I will create a buffer again, buffer of character, and then I will do is I will send this buffer, okay? I'll send this buffer. And if you see, the software got crashed, right? And that is happening over here. And now if you see over here, the EIP value, which I have told you previously, is 41, 41, 41, 41. Okay. So guys, again, thing is that just to reiterate, these all things I have been doing just to kind of explain the theory part and make it much more interesting in a lab part, showcasing the deeper level of how things work in a deep level. If you guys are not able to understand this, feel free to let me know. I will slow it down further. Okay. But that's the reason why I was first kind of covering out the registers values and what EIP, EDX, everything mean. So now I see the next instruction which the computer will be going to execute is has been overwritten with my values, which is EIP 41, 41, 41, 41. So this is something that you see over here. And this is the stack memory that you see. The stack memory is full of A character. Okay. So if I just scroll it up, you can see it's all 41, 41. The whole value, actually there's a buffer overflow attack, and the whole data has been kind of overwritten with 41, 41, 41, 41, right? So now thing is that how can I know which part of that? So my whole task right now as an attacker is to control this EIP value. I know that I can override that at 41, 41, but I want that to be overwritten with a specific value so that it points to my payload. Okay. So what I am going to do is, I will be let me just do one of the thing. Yeah. So this is the code actually which I wrote yesterday. I made a change. To this code yesterday. So let me just figure it out. One thing over here. Okay. So what I will do is normally for exploit writing, what you do is that you actually use this tool, which is called pattern create. Okay. It is one of the part of Metasploit tool. Okay. Pattern create .rb. Okay. And using this, actually, you can create a string. Of let's say of like a random string every time. Okay. A long random string using this pattern create tool. And it is already this tool is already there in the exploit directory of Metasploit. So if you install Metasploit in any system like Kali Linux, if you go to this folder exploit, you will see this file pattern create.rb. Okay. So thing is that with this pattern create.rb, you can create file. But what I was doing is that I was also trying to kind of do it in a different way. So I wrote my own Python script. So what I will do is that I will now run this code, which is Python 3 q1.py, and I will give it a length of 10, let's say. And what it will do is that it will generate me a random string. Of length of 10 characters. If you see, there is no sequence, at least these 3 sequences are not repeating, right? So if I now say it's 100, it will give me a string of, let's say, 100 characters. Okay, it will give me a string of 100 characters, and everything will be like non-sequential pattern. Okay, because previously I was using A. So thing is that I was not able to figure out at what position of A was overwriting the EIP value over here. So this time what I will do is I'll generate this value. Okay, and let's say I write something like 4,000, 400, or let's say I'll say 4,000. Okay, I got this data. So now what I will do is I will copy this part. And I hope, guys, it is making much more sense now that it is actual pen testing and exploit writing. Okay, so Feel free to let me know if you have any other concerns. Okay.